Okay, so this is page 9 of your interactive notebook. You're going to cut out your worksheet that says graphing piecewise functions along the lines, and you're going to paste it onto this full page. So it'll basically take almost the full page. Go ahead and paste it toward the bottom. If you need to pause the video now to do so, go ahead. And so you're going to title it Graphing Piecewise Functions. And the definition of a piecewise function is a function that is defined by pieces of other functions over a specified domain. So what that means is it's not one particular function the whole time. It may be pieces of a function, like part of a parabola. It might be part of a square root function, part of lines, and so forth. And they put them together for specific domains. So for this first example, we have 2x plus 3, which is a line. You should remember from your Algebra 1 days that the line has a slope of 3 and I said that wrong. It has a slope of 2 and a y-intercept of 3. But this is saying we're going to graph this for the right side of the line past -2 and equal to -2. We won't see any part of 2x plus 3 to the left of -2. The other line we're going to graph has a slope of -1. And has a y-intercept of 2. But we're only going to graph it for the left side of the line, all of those values that are less than -2. So the way you do this, you'll notice that I've given you a table. I've set it up for you already. Typically on a quiz, I wouldn't give you this table. You'd have to learn how to do it. But we're taking notes right now, so I've given you the table. So it says that when the domain is bigger than -2 or equal to -2, we're going to use the graph of y equals 2x plus 3. So I've put some points in the table, examples of numbers that are bigger than -2. For example, -2, -1, 0. You could put other values in there if you like, but you always definitely want to have the number that is in the interval that it begins with. In this case, that's -2. You have another table, this time for x plus 2. Doing the same thing. You notice that even though this says x is less than -2, I still put -2 in my table, and that's going to tell me in a second where my open circle is going to go. So you still want to include that, even though it says that it's less than, it doesn't matter. You're still going to want to include that in your table. So like I said, that you can put an open circle there momentarily. But I only use numbers that are less than -2 for this particular table, like for example -3, -4, and so forth. And so I'm going to take these values and I'm going to plug it only into the 2x plus 3. When you do that for -2, -1, and 0, you get the y values of -1, 1, and 3. So the points that I'm going to plot are these here. I'll do the same thing for the second table. And then I'll get these y values here. And so these are the points that I'll plot. So when I go to plot these points, my graph will now look like this. And so notice a few things. So here on -2, -1, first thing you're going to notice is that I closed the circle up because it had an equal to symbol on the greater than. From here, then I went to -1, 1, and then I graphed 0, 3. Technically, from your Algebra 1 days, you could continue graphing this using the slope. You go up 2, right 1, up 2, right 1. So I plotted a couple of additional points. You don't have to do that if you don't want to. But you'll notice you do have a line that has a y-intercept of 3 and a slope of 2. But you only have the right side of that line past -2. You'll do the same thing. You'll plot these points. So you'll start at -2, 4. Notice I now have an open circle. And that was because of the less than symbol on the x less than -2. Then I plotted the next 2 points, but using the slope, I went up 1, left 1, since it has a slope of -1. And there's the graph of the first one. For number 2, if you'd like to pause the video at this point to try it yourself, you could definitely do so. You don't have to, though, if you don't want to. And so we'll do the same thing here. This time you'll notice that I did not pick numbers that were numerically in order. I picked numbers that were divisible by 3 so that when I multiplied them by 2/3 they would give me nice numbers. You definitely don't have to do this. It just makes it easier when you're plotting your points. So I could have chosen, for example, 3, 4, 5 here, and that would have been fine. You just would have gotten some decimals. But because I chose 3, 6, and 9, when I go to multiply this by 2/3, I'm just going to end up with some nice numbers. So you want to pause the video at this point to plug in your points and evaluate. You're more than welcome to do so. Now, for the right side of this, or technically the left side, for the left side of this 3, I did still plug in numbers less than 3, 3, 2, and 1. Technically, that 3 is not less than it, but I chose that so I know where my hole is. But this time it says the y value is 3. What that means is that everywhere you plug in an x on this one, there is no x for you to plug in, so that means the y value will always remain 3. Which means on a graph, you're then going to just have a horizontal line. So you have a horizontal line here at y equals 3, but only the horizontal line left of x equals 3. And so notice I have an open circle here because of the less than symbol. For the right side of 3, you're going to have 3, 2 as your first point. I closed it in. And then from here, technically, you could go up 2, right 3. And then you would go up 2, right 3 from here. So if you didn't want to create a table, you technically wouldn't have to. You could plug in one of the points, in this case 3, and then from there you could go use the slope to graph the rest of the graph. And then finally for number 3, I took away your tables because technically I would do the same thing on a quiz. So for this last one, I didn't give you a table this time. And so when I'm plugging in my points, you'll notice that my domain ranges are a little bit different. This time, it doesn't have a greater than or a less than symbol. It just simply has an equal to or not equal to symbol. That means when you're plugging in points for your table, you're going to want to plug in points that are around the number 5. And all of the numbers around the number 5 but not equal to 5, you'll plug it into this bottom line, negative 2x plus 1. The only single number that's going to use this top one is only x equals 5. So when you get to x equals 5 in your table, you're going to simply plug in y equals 3 for the y value. So for the first part of this, in my table I created, I had x on the left, y on the right. I just started plugging in numbers, negative 2, 0, 2, 4. I included the number 5 and then 6. Once I started plugging those in, I plugged in all of the numbers, negative 2, 0, 2, 4, and 6 into the bottom equation. And you'll notice the only number that I plugged in to the top one is x equals 5, and that gave me a y of 3. When I went to go graph this the first time, I was running out of room because I couldn't get to the number negative 11. So I went ahead and changed my scale on my graph. So you'll notice that I'm counting by 2s only on the y-axis. On the x-axis, I'm still counting by 5s. And then I went ahead and started plotting my point. So negative 2, 5 is here. 0, 1 is here. I continued plotting. But notice at x equals 5, I put an open circle. If I would have plugged it into this bottom one, it actually would have come out to be negative 9. However, 5, negative 9 is not allowed to be there because it said x was not equal to 5. So I put an open circle here. And instead I put a closed circle at 5, 3. Oh, I so put that at the wrong spot. Please do this right on your paper. I forgot I was counting by 2s. So technically it should be here. Okay, and then I continued on my graph for 6, negative 11. So I have a straight line going downwards that has a slope of negative 2, a y-intercept of 1, with one single hole here at x equals 5, and then a dot at 5, 3. And that is all for page 9.